Hello, this is the neutral grounding reactor NGR, which is connected to this neutral of this reactor. This is our 50 MVAR reactor, is a shunt reactor in fact. So it is connected to in parallel to this 400 kV line. This is a Silchar transmission line, because you might be knowing about this Ferranti effect, that if in case of a long transmission line and there is a possibility of the receiving end having more voltage than the sending end, and because of which, to compensate for that or to bring down the voltage level, we have to absorb the reactive power, and for absorbing the reactive power we are keeping this reactor. So the capacity also has been calculated accordingly, and 50 MVAR is the capacity of this shunt reactor. And the neutral of this, as you can see, is because for a balanced system ideally the current should be zero, but practically we may not be possible to have zero current in the neutral. We have to ground this neutral, and grounding, we are not grounding this directly, we are grounding this through a NGR, neutral grounding reactor. So it is grounded through this NGR. What is the purpose of NGR? Is actually, the purpose of this is to help in reducing the magnitude of fault current. If in case the line that we are talking about, this switch line got arc fault or something, then to limit the arc fault current we are putting this neutral grounding reactor. So you can see the placement is like this. So this is actually the final terminal. It is grounded, it properly grounded, because you may think that this is having current, it should have current, but then the earthing also, it's good enough to absorb everything. That's why even if you touch also, nothing happens. And this is our silica gel. You can see the CT is also there, just to for protection system. Whatever current that flows through this, that will be recorded in this CT. So there is a marshalling box also here. Inside this, if you open, what is there inside, you will see the oil temperature indicator. You can see the range from 0 to 150 degrees Celsius, and actually the setting of this also has been provided for both alarm and trip. The alarm setting is 85 degrees Celsius, and the trip setting is 95. That means that if the temperature of the oil, in fact the oil temperature, normal temperature rise is allowed up to 40 degrees Celsius, but if in case it reaches 85 mean this if our indicator, this black one, reaches up to this point 85, then mean it is too high the temperature, it will give you an alarm. But the moment it reaches 95, because our setting for trip is 95, the moment it reaches 95, it will issue trip command. I mean our breaker, our Silchar breaker will trip, but that has not actually happened because there has been no major fault. So this is at the oil temperature indicator inside this NGR, though it doesn't look that big. This is actually a 145 kV class reactor. That means the bushing there that we are using is 145 kV RMS value, and the rating of this, the capacity of this NGR is 40 kVR. 40 kVR. It is big enough, because not much current also, because ideally you should have zero current, but practically that is not possible. And the rated continuous current allowed to flow through this is 10 ampere, and the resistance of this is actually a reactance of impedance 400 ohms. So this is how the placement has been kept directly on top of this SC structure, because not much vibration, because this is just a static device. And also one thing to remember, that the conservator tank also has been provided on top to allow the expansion of the oil, because once especially during daytime the temperature normally goes up, and because of that the oil expanded, and to allow the expansion of oil we are providing this conservator tank. And just like in case of transformer, we have Bush house relay also. This is air operated relay, so in case of any fault, inside internal fault, then the oil, the air will be generated, it will enter the relay, and because of which the alarm and trip contact will get shorted and will trip our breaker, our silchar breaker. And from carrier aided PFCC, the breaker from other ends also, means silchar end also will get tripped. So, and the cooling system of this is oil natural, air natural, that we call onan, air natural, oil natural. That's why we are not installing any fan or pump to this NGR, because normally this is not loaded much, because in an ideal system it has got no functions, but just for protection purpose only we are providing this. So the oil will flow by itself. Yes, so even the PRV also, you can see on top, pressure relief valve also has been provided, and the function of these will be same in case of transformer only, one bushing and like that. Okay, so this is how the function in brief. I have just shown you about this NGR. So the connection is like this. As compared to this our shunt reactor 50 MVAR, I mean the size of NGR will be comparatively smaller, but then I mean it's like this only in all substations that have been installed. This is how, because in college I don't think students would be reading about this, but this is what, when they start working, they will see NGR everywhere in all big substations. So this is the neutral grounding reactor.